Welcome to our video. During this video, we will show you the features of the SIGA-HDT and how to use the tool for troubleshooting issues with signature devices. The SIGA-HDT is a handheld standalone diagnostic tool intended to help users locate and resolve issues during installation or with existing systems. The tool can be used to initialize a signature loop before connecting to a control panel, or it can be used for diagnosis of an existing loop. The SIGA-HDT is shipped with the Signature Diagnostic Tool software, which is part number 7350894, and that software will run on a Windows 7 and Windows 10 operating systems. So what are the functions of the HDT? It can initialize the loop, which identifies all the devices that are connected to the signature line circuit. It will restore the loop. It can perform map analysis on detectors and modules. It will perform a dirty level analysis on photo detectors and identifies detectors which require cleaning. It can perform maintenance on a single detector or module. It will reinitialize the device address of detectors or modules on a loop to zeros. It can perform single device diagnostics, and it can provide a loop history. Important note, when you first receive the tool, the battery is disconnected. You must connect the battery before using the HDT. Remove the battery cover by loosening the two battery cover screws. Insert the battery into the battery holder. Connect the battery to the keyed wire connector. Reattach the battery cover. Then connect the USB charging cable and charge the battery for a minimum of 2 hours before using the tool. Once the tool is charged and you turn it on, you will see the main menu displayed. The options on the main menu are initialize, restore, map analysis, dirty level, settings, loop history, single device history, and diagnostics. When using installation or diagnostic mode, the user must wait 30 seconds for all devices on the loop to power down before connecting to the panel or the SIGA-HDT. Disregarding this may cause problems with the detectors. The initialize loop function enables the device to perform some initial actions such as resetting all devices and opening all isolators. This function uses the device serial number to assign new short addresses, read device addresses, version numbers, device types, shorts on the SLC, and checks for ground faults on the SLC loop. The initialized data is stored in the Stored Database Info page of the display and can be accessed by pressing the Loop History button. If the loop has not been initialized on the SIGA-HDT, the following steps are necessary. First, perform the initialize function to build the SIGA-HDT database. The loop initialized database is then saved to the SIGA-HDT memory. Next, perform other installation functions. Every time a function is performed on the loop, the SIGA-HDT will update its database to reflect the information from that function. If the loop was previously initialized and the loop was disconnected from the SIGA-HDT without any changes to the original loop, the following steps are necessary. First, perform the restore function to verify the number of devices present on the loop. Next, perform other installation functions. Every time a function is performed on the loop, the HDT updates its database to reflect the information from that function. Note, A new database will be created and saved each time the loop is initialized. Always connect the SIGA-HDT to a charger when power falls below 20% in order to keep the functions working correctly. So let's discuss the specifics around the initialize loop process. First, press the initialize button on the touch screen. Next, short addresses are assigned to the detectors and the modules on the loop. Next, details of each device are displayed as the function progresses. A counter displays the total devices along with a counter for detectors and modules. Next, the SIGA-HDT sends a command to all devices to close their isolators and will attempt to find all devices again. The timeout bar shows when initialization is complete. The SIGA-HDT erases the existing data in its memory and saves the new device data to memory. If the save is successful, the saved data icon is displayed. The user may press the X button or icon on the top right corner to stop the function at any time during the initialization process. Press the back button to go to the previous screen. The user may press the module or device counter button when execution is complete, and a new screen with a counter for the device types will then appear. The back button on this screen will take the user back to the initialization screen. Note, number of detectors and modules are shown after the initialize process is complete. Detectors and module buttons appear after processing has completed. Press either button to navigate to the detector or module type counters. Ground fault status will also be displayed after the process is complete. Next, let's talk about the restore loop function. The restore loop function closes all isolators and checks all device status on the loop. First, press the restore button on the touch screen. Confirm if the number of devices on the ReadyCom screen match the expected device counts on the SLC. The user may press the status list on the upper right corner of the restore loop screen to view the device status. Press to select any of the device status radio buttons to display a list of devices in that category. Restore loop will run continuously without the screen going to sleep or timing out. Press the back button to return to the restore loop screen. The SIGA-HDT provides two methods for investigating a new or existing loop installation, and the SIGA-HDT helps to pinpoint specific devices that are causing map faults or have the potential to cause a future map fault. The map analysis function performs the following two diagnostic tests: mapping consistency and contact analysis. What is mapping consistency? The map consistency function maps each device on the signature loop 3 times and compares the responses of all 3 readings to see if there is a mismatch. If a device is not responding consistently, it is flagged as failed and an investigation is required. The possible list of problems associated with inconsistent responses is discussed in the Causes of Map Faults in a Signature Loop section of the HDT manual. The inconsistent response screen shows the status of the devices being mapped and their corresponding counters when the function first starts its execution, all devices will be displayed as passed. Subsequently, failed inconsistent devices would be subtracted from the passed counter and added to the failed counter. Note, the initialize function must be performed first for a new or existing loop in order for the HDT to have a database to work with. The user may see different responses from run to run for the inconsistent response, and the panel may not show a map fault for this inconsistent response. Next, contact analysis. The contact analysis function tests the response measured by listening to devices when the enunciating device is activated. The response is an indirect measurement of the contact resistance and can be used to identify existing mapping issues or devices that have the potential to cause an issue in the future. The user should refer to the list of possible problems discussed in the A Review of Mapping section for further information. Contact analysis maps each end-of-line device and measures the current through each device on that line. The map analysis process. First, press the Map Analysis button on the main menu. The display screen shows the progress from inconsistent device analysis to the contact analysis if mapping was successful. If inconsistent device analysis fails, the mapping would not progress to contact analysis and an Advance button would be displayed. Users are advised to resolve issues with inconsistencies without pressing the Advance button. Select the failed or passed device counter to display detailed information of the devices. The highlighted device will flash its red LED. If the user wants to advance beyond the inconsistent device function, they can select the Advance button at any time. In order to successfully discover the end-of-line devices, the user needs to allow the complete execution of the inconsistent response function. Once the mapping is complete, the previously mapped data would be erased and the current map data is saved to the SIGA-HDT memory. The screen will show saved data once the data has been successfully saved. Dirty level. This function is only associated with photodetectors, and the function enables the user to determine the dirty level of each photodetector on the loop. After the successful execution of this function, the SIGA-HDT erases the old database of dirty levels and replaces it with the new dirty level data. The dirty level process. First, press the dirty level button on the main menu. The counter increments as each photodetector is read and displays dirty level information. The user may press the X button to abort the operation. The function complete will be displayed when the execution is successful and data is saved. Press the counter cell associated with the dirty percentage to be investigated. Press the scroll bar to see more devices on the screen. Press a row to highlight a detector and the detector LED will start blinking or will go steady. Press the back button to return to the previous screen. Note, the counter cells can be pressed to see more details of the detectors within the dirty percentage range. Settings. The settings screen displays the current date and time, The SIGA-HDT needs to be connected to a computer to sync the time and date. The interface and GUI board versions, along with the battery status, loop output voltage, and current, are displayed on this page as well. Press the plus or minus to increase or decrease the screen brightness or shutdown timer respectively. The screen brightness is between 0 and 100%, and the default is set at 60%. The default shutdown timer is 10 minutes, and the timer setting is between 10 and 70 minutes. The SW and HW test buttons are advanced tools which may be requested by technical support or engineering. Note: whenever the lithium-ion battery is disconnected or replaced from the SIGA-HDT, it is necessary to connect to a computer to have the system clock synchronized to the correct time and date. Again, when the SIGA-HDT is first received, it is necessary to charge to full capacity in order to get accurate battery percentage readings. Loop history. The loop history function takes the user to the stored database screen. This screen shows the device information stored in the memory of the SIGA-HDT. If no actions, such as initialize or map analysis, have been performed previously, no data is displayed in the database. The following data would be populated for each device if the functions below were performed. Initialize function would have the short address, serial number, device address, generation, version, and the detector type. For dirty level, you'd have photo detector dirty levels between 0 and 100%. For map analysis, you would have mapping pass or fail data. An NA will be displayed if a particular function was not performed. When you select a device, the LED of that device will be active. Single device history. The single device history displays data only when the single device read EE data function has been performed. The database stores each single device's short address, operation hours, alarm, last alarm bytes, and alarm originator information. When there is no alarm status, NA is displayed on the alarm, last alarm bytes, and alarm originator respectively. The diagnostic menu. The diagnostic menu holds functions that enable a user to run diagnostics on the signature devices on the loop of the system. The normalize photo function. This function normalizes or writes the new clean air count into memory, the photo value of the detector, but it is most particularly helpful when a detector is cleaned after it was determined to be dirty. After cleaning the detector using the approved tools or method, the user can connect the detector back to the loop and initiate this function to normalize the photo value. Next, read EEPROM function. The read EEPROM function is an advanced function which may be requested by technical support or engineering. You can refer to Chapter 5 under Advanced Function for further details. Next, the reinitialize function. This function is useful if the user needs to reset all device addresses on the loop to 0. Part of the reinitialize process will be to press the reinitialize button. Then press the back arrow to return to the diagnostic menu when the reinitialize is completed. Press the initialize button to see updated device addresses. Note, do not use this function if you do not intend to change device addresses. Next, single device function. The single device function allows a user to diagnose a single device within a loop or outside a loop. The single device function consists of 5 sub-functions, which include read EE data, photo AD value, program device address, program maintenance date, and trouble codes. To access the single device function, press the diagnostic button from the main menu page. Press the single device button on the page that appears. Select the single device based on its serial number, short address, or device address. The normalize photo process. Press the diagnostic button on the main menu. Press normalize photo button after detectors have been cleaned. On the counter column of the dirty level table, press the desired counter to view the new dirty level of the photo detectors that have been normalized. Note, the normalize photo function only applies to photo detectors. This is the same as the recalibrate feature on I/O, VS, and FX panels. The read EEPROM function. This function holds sub-function that aid in additional support from technicians. Information stored in the internal memory of the detector or module is displayed here. This information can be useful to technical support for additional troubleshooting. Reinitialize. The reinitialize process will begin when you press the reinitialize button. Press the back arrow to return to the diagnostic menu when complete. Press the initialize button to see updated device addresses. Again, do not use this function if you do not intend on changing device addresses. Single device function. The single device function allows a user to diagnose a single device within a loop or outside a loop. The single device function consists of 5 sub-functions that will include read EE data, photo AD value, program device address, program maintenance date, and trouble codes. Some functions are only applicable to certain device types. The user will select the device in which he chooses to perform the function on. To perform the read EE data function, press the diagnostic button on the main menu page. Press the single device button on the page that appears. Select the single device based on its serial number, short address, or device address. When the EEPROM data for the device is shown, the user will see the manufacture date, last alarm time, and originator, and it will also display the hours that the device has been operating. The photo AD value. This is an advanced function that may be requested by technical support. This function measures clean air values of photo detectors at a particular location. It compares values to the photo value which is programmed in production of the device. It also checks drifting of clean air values from a programmed value. When you select the device and the photo AD value screen is shown, you will see the AD values during production and the photo values at its current location. Program device address. This allows the user to program a new device address. it is applicable to a single device only. This feature is useful for when a system has mapping disabled. This function is active for detectors and modules. Press the Program DA button to execute the function. Select the device which needs to be programmed. Enter the new device address using the keypad that appears. Follow the device addressing guide on the screen to program the new device address. Press Enter to complete the action. Pressing the back arrow will allow the user to return to the single device menu when complete. Note, the user can only program the first address of dual address modules because the second address will be programmed automatically. Also, the user needs to select the applicable panel type on the settings screen. Program maintenance date. This function is useful when a user performs maintenance on a photo detector and needs to update the maintenance date register on the detector. First, press the Program Maintenance Date button. Next, delete the current date by pressing the DEL key on the keypad if the date is incorrect. Next, enter the new date, which has a format of month, day, year, year. And you can do this when using the keypad on the screen. Next, press Enter to complete the action. Pressing the back arrow will allow you to return to the single device menu screen. Trouble codes. The trouble code function enables the user to understand the trouble condition, the possible cause, and a possible solution to resolve the trouble. Trouble codes are displayed during the restore loop execution. If trouble was identified during the restore loop function, you can press the Trouble Codes button. Read trouble code description and refer to the trouble code section of the SIGA-HDT manual for a possible solution. Pressing the back arrow will allow you to return to the single device menu screen. We have a list of trouble codes associated with detectors and modules listed in Appendix A of the SIGA-HDT manual. The ground fault function. Connect a wire from position 10 on the SIGA-HDT terminal block to an earth ground reference such as the panel chassis or ground screw of the panel. The ground fault detection will occur during the initialization process. The HDT can detect grounds on both the positive and the negative wires of the loop. Here we provide some examples of some additional troubleshooting that the HDT can perform. We show a low current difference value related to a detector. The tool will also perform a high current difference value. It can check for reversed in and out wiring at your devices. It can also identify a loop in a loop, and it will also help identify a false end-of-line device. You can reference some additional information with regards to these troubleshooting examples in the back of the SIGA-HDT manual if you would like some more information. That wraps up our video for the SIGA-HDT. If you have any additional questions, please subscribe to our YouTube channel for additional product videos.